Don't worry, I stood up and shouted as well. And I was just going, I don't know what I'm doing.
You're listening to The Cosmic Cast.
Hello, everyone, and welcome to another episode of The Cosmic Cast, brought to you by the Earth and Solar System team at the University of Manchester. I am your host, Marissa Lowe, joined by the wonderful John Penney-Fisher.
Hello.
Ricky Bahir.
Hello.
And Elliot Carter.
Hello.
And our wonderful guest joining us all the way from Los Angeles this week is Eleni Ravanis.
Hi.
Hello. Thank you very much for joining us. How are you doing?
Good, thanks. How are you?
Pretty good. Yeah. How are things in LA?
Great. Yeah, I'm just working from here for a couple of months, and then I'm heading back to Hawaii at the end of this month.
Amazing.
So, yeah.
But yes, so you started your PhD in Hawaii back in January. So yeah, have you had the chance to move there and settle in at all?
Yeah, so I moved there in January. I was there for like 3 months. Then I came to LA for a couple of months because my partner's here, and then I'm going to be going back. On the 27th.
Amazing. And what's it like? I've never been. It's definitely a bucket list place, but how is it?
Of course, it's wonderful, and I'm really enjoying getting settled into the department. So that's good.
That's good.
So as we can tell from your background, you are studying Martian research, but what's your PhD specifically about?
So my PhD is just generally Mars surface studies. But my supervisor is Dr. Sarah Fagents, who's a volcanologist, and also a co-investigator on the MASCAM-Z instrument on the which is on the NASA Mars 2020 Perseverance Rover. So the kinds of things we're going to be looking at are we'll kind of explore like 3 different threads, but at least a couple of them will be related to the Jezreel Crater region and general region, which is a landing site for the NASA Mars 2020 mission. And generally I'm interested in Mars geomorphology, geology, and especially related to volcanic processes. So one of the first projects that we're starting over the summer is looking at doing some ash modeling, like ash fall modeling of potential ash deposits in Jezreel Crater and in the surrounding region, because we can talk about the mission and the landing site and things, but there's a bit of a complicated geological history there, and potentially some ashfall deposits. So we're going to be looking around the region for some potentially volcanic features and modeling, if this was where the deposit came from, would it match up with what we see in the rock record? So that's going to be fun.
Yeah.
That's really cool.
What actually is the MASCAM-Z instrument?
So the MASCAM-Z instrument is, I tend to talk about it as a camera, but it's actually a camera system. It's 2 identical cameras mounted like 6 feet above the 6 feet. I'm turning American. 2 meters, 2 meters above the Martian surface on the rover's like mass. Oh, look, I have a prop.
Oh, lovely.
So not sure if you can see there's kind of two cameras here, and the difference between the 2 cameras, that they're near identical, but they have slightly different filter sets. So the wavelength range is something from like 400 to 1,000 nanometers. So we can take multispectral images, and we can also take images and make 3D products and videos. Maybe you saw some of the videos of I'm not sure if my hands disappeared, but there's a little Ingenuity helicopter behind me as well. So yeah, it's kind of there's a lot of cameras on the rover, but it's like some of the main eyes of the rover. So we use MASCAM-Z for kind of context imaging, and then we use some of the other instruments maybe to look in a bit closer at targets of interest.
So how was it being part of the mission when everything's been, landing and seeing the excitement of all those first images and videos coming back?
It was really exciting, super exciting. It was a little bit nerve-wracking on landing day. I mean, I tried not to think about it too much, but it did occur to me afterwards. I was like, if it didn't go well, was that my PhD out the window? But yeah, and I was mainly, hoping it would go well for everyone, and also my colleagues who've been working on the mission for for years. So I was really happy when it landed safely, and it's been really exciting to get involved. I mean, my supervisor kind of described it as drinking from a fire hose. Like, it's a lot of information and a lot to like take in all at once. We were doing 7-day operations at the moment, so other than some solid days as they're called, like when we have a day off here and there, it's science discussions every other day, and then in between those days there's some discussions about called campaign implementation discussions, which are about the kinds of observations we'll take, and there's lots of working groups to get involved with. You kind of want to join everything because it's also interesting, but then you'd be on WebEx all day and it wouldn't work. But it's really interesting, it's really exciting.
So are you having to work on Mars time as well? That's the thing that's sort of do, I believe.
Yeah, so luckily we've moved to modified Earth time, which is the shifts can go from I think it's 5 a.m. to 12 a.m. Pacific time. So when I go back to Hawaii, that will still be 2 a.m. in the morning. So, but we did work on Mars time for the first about 60-ish sols, Martian days. And yeah, so there was a few weeks because it goes around the clock, obviously, because the difference between the time it is on Mars compared to the time it is on Earth changes, because the Martian day is about 37 minutes longer than Earth day. And yeah, there was a few weeks where we were all kind of up in the middle of the night. My supervisor and I had a meeting at 1 a.m. and we were like, this is a really weird time to have a meeting, but this is the life we're living now. But it was fun, and really fun to be for me to get involved with some of the operational things as well.
Yeah, I mean, so I guess do you have the opportunity then to be some of the first people to see some of these images that come back from such a sort of flagship instrument like this?
Yeah, so I mean, I think it's really great because some of the most exciting images that we've seen, obviously, as a Mars 2020 team, we do see them slightly quicker than they get released sometimes, but actually a lot of the principal investigators for the instruments are really keen about getting the data out publicly as soon as we can. So sometimes we're all seeing these new images together, which I think is really exciting. But I've been working I'm a student collaborator for the Mastcam-Z instrument, and I've been working on the downlink side of things, so the data we get back, and I've been helping with the science support team. So we have different people on a daily basis working to make some multispectral image products for example, for some of the multispectral data that we take, and quick look products, so that we can give those to the wider Mars 2020 team and start to have a look at a new scene or something like that. So that's quite exciting, because we're some of the first people to get a good look at at the rocks and what we're looking at, and try and work out if there's anything interesting there.
Yeah.
So when you talk about these multispectral images that are returned, so obviously we can visualize a normal camera image that you can get from it, but what do the different spectras actually tell the scientists about the image itself, or the surface itself?
Yeah, so I mean, some of the simple products that we make is so we can kind of exaggerate changes in the scene to try and pick out, for example, the wavelength range of Mastcam-Z is particularly good for trying to pick out iron oxides and hydrated minerals, and there's certain data products we can do to try and pick those out by ratioing the different spectra, or stretching the spectra and things like that, and we make pretty pictures that sometimes look a little bit like pop art or something. They're very colorful, but they help tell us about what's in the scene, and the variations in those colors can be due to texture, grain size, composition, and they're also affected by viewing geometry. So you have to take everything with a pinch of salt, and you can't decide that, okay, this rock is this just based on this image. You have to think about all the different context around it. but it tells us more than just looking at it how we would see it with our human eyes, if that makes sense.
I guess it's super important, not just for scientific analysis, then it's also important for the rest of the rover team to know what they want to do next, where they want to sample, etc., and things like that. So
exactly, yeah. So the rover also has a number of other cameras, like for navigation and things like that, but the Mastcam-Z is super useful for, like you said, knowing where we might want to have a look. And we haven't started sampling yet, but we're going to move into our first official campaign in like a week or two, I think. And at some point soon we'll start sampling things, so that will be ready to hopefully bring back to Earth, so that will be really exciting as well.
So yeah, you said that part of your PhD research is going to be looking at the maybe volcanic history in Jezreel Crater. How much do we know about Jezreel Crater already? And what sort of information do we already have?
So yeah, so Jezreel Crater is a really interesting place. I mean, that's why it was picked to for Mars 2020 to go there. But it's got a delta in, at least one delta deposit, and it was filled with water at some point, and it might have just had a lake, and then the lake went away, and that was it, or it might have filled and gone away and filled again and things like that. So there might be quite a complex history there. And in terms of volcanic rocks, it's near the Syrtis Major region, which is a volcanic province, but over the years it's been suggested that parts of the crater floor are volcanic, like some people suggested that they might have been formed by lava flows, or also ash deposits, which is where some of my research comes in. But right now we're not sure what all the rocks are, basically. And hopefully, we hope to find out more as we go around with the rover. But it's been quite extensively studied from orbital imagery, because it's an interesting place, and also especially because Mars 2020 is going there. So yeah, we know it had water in. We know that some interesting things happened as well, potentially volcanism, and also one of the most interesting things is this kind of olivine and carbonate bearing unit. So that this olivine unit might have been formed by some kind of volcanism, but then been altered by water. So there's some interesting things going on there that we're trying to explore.
Yeah, it's always exciting when sorry, do you want to go, Elliot?
Oh, sure. You were saying about potentially ash layers there. So was the explosive volcanism on Mars? I tend to just think of enormous basaltic shield volcanoes, like I think Olympus.
Yes. So that's another reason why it would be interesting to explore such ash layers, because they think that there was explosive volcanism earlier in Mars's history, and then it changed into more effusive volcanism. But that kind of balance is something that people are still looking at. And the other reason it would be interesting to find an ashfall deposit is because like volcanic deposits would be really useful for sampling for absolute age dating in geochronology. Because I feel like sometimes the fluvial deposits get a bit more of the attention from the astrobiology side, because kind of clay deposits are thought to be good to target, as they're generally good at preserving biosignatures. But we need to remember the volcanic products as well.
There's volcanic ashfall, well, potentially ashfall deposits. They're quite widespread as well, aren't they? They're not just in Jezreel Crater. Yeah,
exactly. So the potential ashfall deposits that we're looking at modeling, the deposit that's in, well, whatever it is, whatever's in Jezreel Crater, it might be related to regional kind of olivine carbonate units. So if it did turn out to be an ashfall deposit, they could be related, or it could be, different depositions. So there's a lot of interesting things going on.
Yeah, it's just incredible to think about. You have this little rover that can sample a deposit, really like an in situ close deposit, and learn about such a large area of Mars
Yeah.
just from doing that. Yeah.
Exactly, definitely. It's not that little actually, the rover, if you think it's more like a Jeep. But yeah, but
So I guess like I guess a lot of then of how you're sort of thinking about your PhD in the future, I guess, depends on the sort of results you get back. So I mean, how is it quite sort of stressful then to sort of think about how your project might change and shift as the results come in and then things sort of develop over the next few years?
well, yeah, I mean, it's exciting and for me, and it's also nice that I'm flexible because I think you know, in the US it's a slightly different system. In the UK you tend to, because I also applied for some PhDs in the UK, I wasn't sure where I'd end up, and you tend to kind of go in with a specific proposal or a specific project that you have funding for and focus on that, not always, but generally. Whereas because my funding comes from Mars 2020, and because of the way the system works, at least at my university, I can kind of my PhD is going to be kind of 3 chapters, and they have to be, you know, related, but they can be quite different. So what my supervisor and I are looking at doing is we do want to explore things specifically related to Mars 2020 and to the Jezreel Crater region, but we're also interested in just more general Mars things. So for example, for my master's degree, I looked at trying to automatically detect Martian caves with machine learning. So I have some other interests that maybe I'd like to return to. So that wouldn't specifically be in the Jezreel Crater region. So there's lots of other interesting places on Mars that I might get to explore.
That might be a good point to ask. How on earth did you end up, you know, studying Mars while in Hawaii and, you know, getting up at all sorts of crazy times and working with NASA and stuff? How did you get to where you are now?
Yeah, so well, it's probably worth mentioning that I'm British, as you can probably tell from my accent, and Greek, but I grew up in Leeds. So you know, I'm
Nice.
quite excited. Yes, I'm quite excited to be talking to you guys.
Ricky's
and
a
I did a
fellow
batch.
Leeds fan.
Yeah, I'm from Leeds. That's
Yeah.
why.
Oh, good. I thought, I was thinking your accent sounds familiar.
What do
I
you
was
call
just
someone
like,
who's from Leeds? A leader?
You sound great.
Great, yeah, fair
Yeah.
enough.
yeah, Yorkshire man or woman, I don't know.
Anyway, sorry.
Okay. But yeah, I actually did my bachelor's in geography. But I was always interested in space things. And I'd never really heard of planetary science, I think, when I was at school. I feel like maybe it's changing now, but I feel like it's more of a thing in other places. And even though we have a fantastic planetary science field in the UK, it's not really something I knew about as a field until I was at university. So I did a bachelor's degree in geography, but I did that at the University of Sheffield, and I spent my second year at the Australian National University, and that was my first kind of exposure to planetary science. Like I took a planetary science module and I really liked it. And I also actually at Sheffield for a module we got to kind of pick any topic we wanted, and my supervisor suggested these gullies on Mars may or may not be formed by water, and kind of these different threads about landscape but on Mars like piqued my interest. So basically for my bachelor's thesis I looked at Martian gullies and recurring slope lineae, which when I was doing my thesis people thought were formed by salty water, but the jury is still out on that for now. So yeah, I did my bachelor's degree in geography, and then I did my master's degree in planetary science at UCL. And then I spent 2 years in Spain working for the European Space Agency for the Mars Express mission as part of the Young Graduate Trainee Programme. So there I was working in science operations specifically for the visual monitoring camera instrument, which was originally an engineering camera that was to monitor the Beagle 2 lander, which unfortunately failed. But the camera was still there. So long story short, they were using it to take images for outreach, and then they found that we could actually do atmospheric science with it. and then it was designated a science instrument. So the work I was doing at ESA was kind of contributing to making it a full science instrument. So I was involved with planning the observations that the camera takes, but also in making and maintaining a data processing pipeline along with my colleagues, and also archiving that data on the Planetary Science Archive. So I did that for 2 years in Spain. And then, this January I moved to Hawaii to pursue my PhD. And the PhD opportunity was perfect for me because I wanted to go back to doing slightly more of the science side of things, but also maintain an involvement with an active mission and mission operations. So when this PhD came along, I was like, oh, this sounds great. And it's not bad that it's in Hawaii either. So.
Yeah. I mean, that's
How
really
was it
cool.
moving with the pandemic?
Oh, sorry,
Oh, it was interesting. Because I had a bit of a journey from Spain to the UK, actually to Greece, because my partner, who's Greek, had to move at the same time, and then to mainland US, and then to Hawaii. So it was it was difficult to try and do everything as safely as possible, but I managed, so that was good.
A longer trip than the rover that you're studying now.
Not quite. almost.
Yeah. The young graduate training program sounds really cool. Like, I know quite a few people who applied for that at the end of undergrad, but it must be really competitive because I don't actually know anyone who got it. Is that something that's still running? Like, is that, yeah?
Yeah, and it's 100% worth applying. I mean, so there's kind of two main opportunities for early career as in pre-PhD, because post-PhD there's the research fellow program as well. But yeah, so there's the you can apply to be a student trainee, which is generally projects from 3 to 6 months, and that's whilst you either are have kind of, it's mainly for master students who are still pursuing their masters, although sometimes bachelor students end up doing it as well. And then the young graduate trainee program, which is full-time employment, paid, everything, is for people who've completed a master's, but you can apply whilst you're still doing your master's, which is what I did. And it's generally for a year, but sometimes there's the possibility to extend it for another year, which is what I did. And generally applications go online every year, and they're open for a month. And there's lots of different opportunities, and engineering opportunities, more science focused. Also, there's sometimes some positions in administration, in outreach, things like that. So it's a really good program.
Yeah, it sounds really cool.
Yeah.
It sounds very cool, like having a whole team of people that you're working with. Like, PhD can be a bit lonely, I think everyone will be agree with that.
Yeah, I'm lucky. I'm feeling quite grateful for that, because especially during the pandemic, like because we're all working in different places, it's not felt that weird in a sense, because we're all on WebEx and things. And I mean, the only thing that's a bit of a shame is that if it wasn't for the pandemic, I mean, apart from all the obvious things that are a shame because of the pandemic, we would have been going to JPL for the landing, and we would have had like 2 or 3 months of everybody being at JPL and doing the operations together. So it's a bit of a shame that we don't get that, but hopefully at some point when it's safe to do so, we'll have like a big team meeting and get to meet some of these people that we've just kind of only seen in 2D. So that'll be nice.
Yeah, we've got at the moment we're doing simulations for ExoMars, and ours is exactly the same thing. We've got like 80 people on a WebEx meeting, whereas we'd actually be at the ROC, the Rover Operations Center. Otherwise,
the ROC. That's a good acronym.
You can't steal it. We've got it.
I'm not going to steal it. Yeah, that sounds really exciting. So, sorry, you're a research fellow at S-Tech, did you say?
Yes, yeah.
Yeah, okay.
Yeah, so my research is to do with fluvial systems. So when you were talking about the gullies stuff, I was actually at like the first meeting where they started to go, oh no, they're actually made by CO2 sublimation. the gullies.
Oh,
And there were
yeah.
people standing up and shouting at each other, going, "No,
Oh
it's
my
not.
God.
It's made by briny water." And the other people, and I'm like,
Really?
I just finished my master's, and I was like, I've never done anything to do with Mars before. Don't know why I'm at this meeting, but
Yeah.
people are
God,
really
I
heated
bet.
about this.
Yeah, I mean, I guess it must have got pretty tense, but
Yeah.
yeah, it's interesting because when I did that for my bachelor's, like when I was in my second year of my bachelor's, I don't know if you remember, but there was a particular paper, I'm going to pronounce this wrong, but it's like Okja et al. 2015. It was that one where all the news outlets were like, we found water on Mars.
Yes,
It's
yeah.
really salty, but yeah. And I, it was like a thing. And now it seems like it kind of quietly gone away. So it's interesting how these things evolve.
Yeah, it generally seems now, just I know everyone else here wants to hear about this. They generally think now that it's CO2 sublimation. So it's CO2 ice underneath the regolith, and then that sublimates, and then it causes the regolith to collapse, and it looks like a river, essentially, like a short river or something. But it's not. But I don't know. I study actual river, well, the rivers that were there. I study valley systems on Mars.
You're
So-
lucky,
Okay,
like
cool.
most of us don't know enough about this, otherwise we'd be standing shouting at you right now.
Yeah. Don't worry, I stood up and shouted as well. And I was just going, I don't know what I'm doing here. Yeah. Right.
So Eleni, there's like so many interesting things I want to go back to, like in the conversation we have just had. But one of the things you mentioned was you did your master's project on using machine learning to find like Martian caves. Was that right?
Yes, yeah. So I looked at trying to, together with my supervisor and a PhD student, Alistair Francis at Mullard Space Science Laboratory. We looked at trying to detect like the surface features of caves, so specifically skylights, which are the kind of collapsed roofs of lava tubes, and also generally pits that look like they could have some kind of surface cavity beneath them, because there's quite a few kind of weird looking deep dark holes on Mars that we don't really know what they are, but it looks like there could be a cave or at least some kind of space beneath them. And so for my master's project, I looked at trying to detect those features with machine learning by training an algorithm to detect these features. So I had a little over 100 examples, which is not that many when it comes to machine learning. So I had to do some interesting things of kind of like synthetically extending the data set. So that was kind of the technical side of that. And the reason that I was looking at those to start with is because we think that the subsurface of Mars is probably one of the most interesting places to look for either preserved biosignatures or even like life that potentially still exists. So that was why I was looking at caves, and also because, if we send humans there at some point, maybe that's a place that we'd want to look at, because it's more sheltered from radiation than the surface. There might be ice deposits in those caves, things like that. So they're definitely an interesting feature on Mars.
Are some of these caves associated with methane hotspots as well, or have I just made that up?
I'm not sure if the caves definitely themselves are associated with methane hotspots. I mean, the whole topic of methane on Mars is still kind of a bit controversial in some respects, but so Mars Express, which I worked on, published a paper I think last year or the year before, corroborating some of the findings of the Curiosity rover with methane spikes. And I remember looking at the paper and thinking, oh, it's quite interesting where they were suggesting some of that methane comes from. So they think perhaps maybe it might be locally sourced. But the problem with the methane on Mars is that the trace gas orbiter, the ExoMars trace gas orbiter, hasn't detected methane, and so we would expect it to, because the sensitivity is higher than that of Mars Express. So, but Curiosity sees it, and so does Mars Express. So it looks like something weird is maybe going on. Maybe the methane is getting broken up much quicker than we think it is. So it's definitely an interesting topic. Yeah.
But on the subject of the lava tubes, you're talking about how they might be a good place for microbial life, for instance, if there ever was life on Mars. I guess that's because it's far enough below the surface, so it's not destroyed by ultraviolet or cosmic rays. So I guess that takes you full circle back to why Jezreel Crater is important, because the whole point of the mission is to try to look for ancient signs of life.
Yeah, definitely. So as I mentioned, there's a delta that was in Jezreel Crater, and we think it's a really promising location to look for preserved biosignatures of ancient life. And as I mentioned before, some of the kind of fluvial and lacustrine deposits and some of the fine-grained clays that we expect to be in the crater are some of the best sediments for preserving biosignatures. So there might have been life in Jezreel Crater. There might have been life kind of upstream in the watershed region of Jezreel Crater. So that's why everyone cares about the water. Well, not the only reason that everyone cares about the water, but that's one of the reasons that we're looking in this area.
What would the biosignature look like if they found it?
Well, I think it will be really cool one day to just go along and see a fish, but I really doubt that I really doubt that's going to happen. I think that if we do see something, I mean, it's difficult to tell. I think that we won't know some things for sure until hopefully we bring the samples back to Earth. The kind of biosignatures that we're looking at would be really, really small probably. And for example, there might be certain, we might not see it's not like necessarily that we'll see a fossil. We might kind of see evidence, and from that particular evidence of this, like this compound, we can kind of deduce that that's most likely formed by microbial life or something like that. But yeah, it would be much cooler to just kind of walk along and see a fossil, I think.
Yeah.
But I doubt that's going to happen.
Because I think even in the case of ExoMars, we have an instrument called MOMA on it, which unfortunately I can't remember what the acronym stands for, but it looks for just organic matter that would be resembling of something that would form by life, or like a byproduct of a bacterial life, or at best we're looking for things like stromatolites, so some kind of formation that is formed by life, as opposed to looking for some bacteria that's moving around on the surface.
Exactly. Yeah. So that's the kind of thing that that Mars 2020 is looking for as well. And I'm super excited for when ExoMars gets to Mars as well. So the more missions looking for life on Mars, the better.
I kind of have a curveball, and it's on. I guess everyone could throw their 2 cents in if they like. What do we do with human missions if we do find life on Mars? Like, do we just still send humans there to Mars?
What do you folks think? I would be really interested to know.
I mean, it's a conversation, I guess, that hasn't really had to happen yet, is it? I guess, but yeah, I mean, it's that balance, that question of preserving pristine habitats. It's not just Mars really as well, but the Moon as well in many ways. That, you know, how much by us sending rovers and by us going there, you know, we're obviously damaging these pristine environments that have been preserved for billions of years. And, you know, I guess we probably need a broader discussion within the community about what we do to preserve these kind of environments. I guess obviously when there's life involved, it's a bit more tricky because you start worrying about, you know, what weird bugs and stuff might be out there that could affect us. But I mean, more generally, yeah, I think it's difficult, isn't it? Because you want to study it, but at the same time you want to preserve it.
I guess that kind of segues us into the idea of ethics in space, right?
Exactly, it's hugely important.
Yeah. So something we were chatting about offline with Eleni is that you've been involved with the Space Generation Advisory Council, which is looking at exactly these sorts of issues. So yeah, you'd probably be the best person to explain what that is.
Yeah, sure. So I'm part of the Space Generation Advisory Council, SGAC, Ethics and Human Rights Working Group. And some of the questions that we were just talking about are exactly what we're thinking about. So I'm involved with that group specifically. And one of the projects that we're doing right now is that we're trying to create like a space ethics library, as we've called it, like an online resource where we house like reading, journal articles, news articles, podcasts. We're trying to categorize things and split things into reading, listening, and watching, so that people can kind of start exploring some of these ideas in a way that suits them. And also outside of that group, kind of in my own time, I'm involved with some like space ethics related things. For example, some of what we were just talking about, if we find life on Mars, what does that mean for human missions? What do we owe it to these places, which are currently pristine-ish? We've kind of littered Mars a little bit already, but yeah, what do we owe it to them to and to ourselves to preserve them? And one of the things that I was involved with recently is as you probably know, the NASA Decadal Survey happens every 10 years, and it's a chance for the planetary science. So the planetary science and astrobiology decadal happened recently, and it's a chance for the community to kind of give their thoughts on what some of the main considerations should be. And there's different portions of that decadal survey focused on the science, focused on mission concepts, and another portion is focused on the state of the field. And together with I think it was 11 other co-authors, we put in a paper about ethical considerations of planetary protection, and being anti-colonial in some of the things that we do in space. So it was just a short paper, as the white papers are 7 pages. It stirred up a little bit of fuss among some people, because I think sometimes people think that some of these like planetary protection measures and some of these thoughts are people saying either, number one, we shouldn't send humans at all, or people are too quick to want to go. And it's like, for me personally, I would consider myself kind of pro human exploration. I want to send humans to the moon and Mars because I want us to explore, but I want us to do it ethically. I want us to think about what we're doing, because the things that we do now are going to have impacts way beyond our lifetimes. So these are really interesting considerations to be having. So that's something that I think the conversation is coming up more and more in the field of planetary science.
Yeah.
And yeah, this SGSE working group is, the SGSE in general is an organization for young space professionals. And with the group, we're hoping to kind of keep having these conversations, have some projects looking at how they relate to the UN Sustainable Development Goals and things like that. So I'm excited to be involved with the group.
Yeah, that seems hugely important, I guess. So in your work in this group then, have you felt that the community has been quite responsive so far? Have you had quite good dialogue with the wider planetary science, or have we still got work to do to bring these sort of matters to the attention of the community?
I think a bit of both. I mean, thankfully, like most of the conversations I've had so far with the planetary science community have been really positive, and the reaction to the white paper that we submitted to the NASA Decadal Survey was mostly really positive. I think we still have a bit of way to go because some of these topics can seem quite inflammatory. I think some people who, we're all really interested in space. That's why that's why we do what we do, and I think sometimes these considerations are viewed like an attack on space exploration, when I don't see it that way at all. I think that they're a way of making, thinking about what we're doing is a way of making space exploration better for everyone. So yeah, I think I'm really hopeful, because I think these conversations are becoming a bit more mainstream.
Yeah, for sure.
And because people have been doing this work for years, and that's part of the reason that we're creating this space ethics library resource, so that the work that's already there is, hopefully gets the attention it deserves, and we can build on that and bring that into the planetary science and astrobiology community more. But yeah, I'm very positive about the future. So
sounds good. Well, we can put a link to that resource in the episode description, and if people want to find a bit more about
so
it.
it's it's not live yet. We're still
Okay,
in the
right.
in the drafting process, but we are hoping to bring that out kind of at the start of June. So hopefully soon.
Cool.
On top of doing all of that stuff, you've also been getting involved with like science blogging through Geobites. So yeah, how has that been? What sort of topics have you covered so far?
Yeah, so I've covered Mars related topics so far, and planetary science related topics in general, but generally Mars related topics. And it's a really great blog that started. We have a lot of different writers, and we have both Earth and planetary focused blogs. And the idea of the blog is that everyone reviews a paper and kind of says in like 500 to like 800 words the main themes from the paper. So I think it's a really good way to make journal articles accessible, and I've really enjoyed writing for Geobites. It's helping me communicate science better, I think. So I would definitely recommend that people check out those pieces if they're interested in reading some more science.
Again, we'll put a link below, but it sounds like a win-win. The public get to easily access science and you get to read more papers.
Exactly.
Yeah.
And I don't know about you guys, but I find that sometimes writing about a paper or something really helps me, or explaining it to someone else really helps me with my own understanding.
For sure.
So I've really enjoyed writing them for that as well.
Yeah,
that sounds super useful. I'll definitely check that out.
Yeah.
I think it might be time to ask our final question. Yeah.
Yes, indeed.
That's
The final question. So this is a question we ask all our guests who come onto the podcast. And so really the question we have for you then is, if you didn't go down the road of becoming a planetary scientist, what else, either in science or generally, do you think you might have done with your career?
Ooh, that's really interesting. I think if I'd gone for science, I might have gone down the maybe that's too closely related, like the earth science route, because I started in geography. And when I started geography, I wasn't sure if I would be more interested in like the geopolitics side of things or the physical geography. It turned out to be the physical geography things. But if I hadn't gone into science, I think when I was younger, I always wanted to be a writer. And I still want to try and like combine my like love of writing with science throughout my career. I think that as scientists, we do have to write a lot, and that's something that you don't realize when you're at school and you think about being a scientist. But yeah, I think if I hadn't ended up in science, maybe I would have done something in writing or music or something like that.
Fictional writing.
Yeah, and non-fiction writing, but yeah, I'm a big fan of sci-fi novels and things like that. So
Still time.
it's nice to fantasize about being something like that.
Yeah, that is a good point. I feel like in school you'd push down either English and arts, or you go down maths and science, and it's like there's so much crossover between the two. Yeah.
Exactly.
Yeah.
So for all of our other guests we've had on, that was the best answer we've had so far. So you guys need to step up your game. That's all I'm going to say to everyone.
The gauntlet has been thrown down.
Yeah.
But yeah, I feel like we could have chatted to you for hours about all of this, Eleni. So thank you very much for giving us your time and for so much interesting discussion.
Thank you.
But yes, we will pop down in the description box the links to your Twitter and all the bits that we mentioned. And if any of the listeners are looking for any more Earth and planetary science content, all the links for our Facebook and Twitter and Instagram are on the screen or in the description box. So all that's left to say is thank you again, Eleni, and thank you to all the listeners at home.